Tonight we have Jonathan Moore. He's going to be talking about Saturnalia.
Saturnalia
DB.
like Saturn.
Okay, there we go. I tend to butcher names. Tonight's sponsors, we have Percona for the food. Thank you. They're always hiring very highly skilled DBAs for consulting work. They're also a really good consulting company, so if you're looking for some help with your MySQL installations and performance of your sites in general, check out Percona.com. Our host here in the facilities tonight is CBS Interactive. They are formerly CNET. You might be more familiar with that name. They have a whole host of different sites. They help support the meetup community. They're looking for basically a wide range of technical people, a lot of different sites looking for a lot of different things. They're looking for something in their data warehousing team, I believe with Hadoop. If you're interested, check out cbsinteractive.com/jobs. Also sponsoring tonight, we have O'Reilly. They're raffling off 3 books, so we'll do that at the end. O'Reilly is also giving us a ticket to Open Android Conference. I forget when that is, coming up soon, but we'll be raffling that off as well. And our other sponsor providing my time and some of the food and stuff is IGN. We mostly just, like Percona, like helping out the tech community. Next month, October 17th, Akabon will be giving a talk about high-performance indexing. And then on November 15th, Percona will be giving a talk about Percona's toolkit, which is kind of the, I don't know, successor to MapKit, or is it? Yeah, so it's a bunch of stuff rolled into one. It'll be a good talk. Aaron, am I forgetting anything? Continuant is sponsoring. Yes, thank you. They're a new sponsor. They're working on giving us a custom logo and some new signs and stickers and fun stuff like that. So we'll have some of our own swag to give away for a change. Now I got everything right.
Now open it up to everything.
Right. Yeah. Sorry, it's been a long day. But does anybody have any quick announcements? Looking to hire, being hired? Go for it, Ryan. You're a sponsor.
I actually have 2. In addition to hiring, we're also having a training course, 4 days of training in San Francisco on the 26th, and we're going to raffle off a ticket for that tonight.
Oh,
and
sweet.
I just wanted to let everybody know that the Percona Live MySQL Conference and Expo call for papers is open, so if you've got something interesting to talk about, go ahead and submit a proposal. You can submit it at perconalive.com.
Anyone else? Go for it.
Yeah, hi, I'm Rob from Wikimedia Foundation, and we're hiring for several positions, including assistant engineer for analytics and a software developer for analytics. So, job descriptions up on jobs.wikimedia.org. Thanks.
Anyone else?
From Modulocker, we are looking for a software developer experience with the whole damn stack. If you're interested, come see me afterwards.
Cool, cool. And if there's nothing else, we'll go ahead and turn it over to Jonathan and learn something new.
All right. Put that there so I have to bend down. So really briefly, this is a project that started about 1.5 years ago in my spare time, and then started working at Spinner because we felt pain, and then we decided it was actually kind of neat, and maybe we should just spin off a whole company around it. So that's sort of where this started. So it's about 1.5 years old, but has had increasing development put in. At first, just spare time here and there, and then started increasing over the time. So anyway, so representing on Saturnalia DB, it's real-time analytics. I use time series database. It's I don't know, not quite sure the tagline's final, but so it's where we're starting at tonight. So why am I here tonight? And I'm here tonight because we can't see, and it hurts. So, but before I really get into that and explain to you what I mean, I'm going to give you a really quick demo just to give you some context of what we built. I'm going to have a longer demo later, but I just want to show you what we're talking about so you can sort of contextualize, because I've got a whole lot of technical shit to talk about. We can go into various depth, but I wanted to give you some context. So here is sort of our dog food site that we can, that just has some Spinner content. So Spinner is a basically like a real-time web crawler. We crawl or Spinner crawls the live web, which is social media, news, blogs, that kind of stuff. And so this is a little site we're using to test out internally, and we are going to switch to, hopefully quite soon, of this tool. You can see it looks similar to a lot of stuff you've seen, but some of the cool features we have here is that, this thing is interactive, and we can zoom, and we can see like, oh look, that little dip, that's actually kind of an interesting trough, and we can do all that kind of stuff. And there's a lot more features, but I wanted to see that this is the kind of platform we're trying to build before I go into the talk. So just a quick sort of context for what we're talking about. So the basic problem we're running into is that our systems are really data rich. And just as a few examples, I mean, I was just, if you start thinking about it, like if you have a dual quad-core Nehalem, you have 8 cores with 16 execution threads, and you might want to look at like CPU idle and CPU wait. In fact, there's 8 different basic metrics you could look at, and just alone, that's 128 metrics to track, just for those 2 CPUs. If you look at perf, which is a really awesome Linux tool, which if you don't know about, you should look at, which lets you do performance tracking of in-kernel stuff, whether it be the CPU counters or your the VFS files, VFS syscalls, whatever. There's there's 1K metrics you can track in perf. We're looking at information schema on one of our installs today. There are thousands of metrics in there, and some of them are really cool. Like, wouldn't you like to know how quickly your database tables are growing? And then on my desktop box at work, there are 12K open files. And if you're trying to analyze some I/O problem, you want to know what's going on with the files on your system. TCP stats. If you've got a lot of connections, especially if you're running a public-facing service, a web server or some other kind of thing, like, when customers complaining about performance, wouldn't you like to know, like, how many resets are we seeing on their connections across the board? What are the TCP send windows? What does that stuff look like? Because a lot of times that's the problem and not you or them even. And then, like, your application stats. I mean, how many stats can your application produce? Like, what are all the things you might want to track? And you might say, but I don't need to track all of those. Those aren't my core metrics, right? But history really matters. When you're having a degraded performance situation, when your application's not working the way it's supposed to, and you're trying to figure out what the hell's going on, you can go turn on those stats you don't normally track, and you can go look at things in proc, and you can see that the value of this metric is 73. Is that a normal value? Is that what it was before? Is that high? I mean, maybe this disk utilization time. I mean, that's one you normally watch, but was it high before? Is this its normal utilization? So really deeply, we think that you really want to know the history of everything, not just be able to look at its current values. So we really want to try and make things trackable. So there's some current options for tracking stuff. So first talk about on the back end. So there's sort of 3 classes of tools. There's really only one NoSQL kind of GUI tool, OpenTS DB out there. And then you have RD-based tools and SQL-based tools. RD-based tools for our database, have some shortcomings. It's a ring buffer. You have to decide when you start recording stats, how long you want to keep them for. And not only that, it only has the high-resolution stats for part of the size of its buffer. It throws away the high resolution. You can look at a year maybe, but only maybe the last week of that is with any resolution. So if you want to compare this week to what it was last month, you probably can't do that. Also, from an I/O perspective, RD stores every stat you want to do in its own file. So clearly, if you wanted to track 1,000 stats and you wanted to track with 1 second resolution, that's 1,000 IOs a second. I mean, that's an expensive driver write. Now, some people get around this by writing to like tempfs or something like that, and then like rsyncing or some other way, copying it to some things. They have snapshots that are hopefully consistent and hopefully will read when you try and write them later. But who really knows? And you only do that periodically, so if that were to go down, you could lose minutes, or depends on what your sync rate is stats. You could lose a lot. Also, it's not a terribly efficient format. It's not horrible, but it's not terribly efficient. And it's using stuff on disk. And now, if you didn't want to ever, if you don't, for old stats, archiving stats, it doesn't really matter how big it is, because disk is basically free if you don't want to read that stuff. I mean, the rate, if you look at graphs of how quickly disks are growing and how quickly throughput is going and how quickly IOs are growing, those are decreasing curves. So it means any particular block on disk is essentially necessarily getting cooler over time. You just can't possibly access it. We're going to pretty much soon get to the point where our disks are large enough that you couldn't fill them up in the MTFB of the disk. I mean, that's clearly on the horizon the way these graphs are going, unless they increase MTFB. So then there's SQL-based tools. And SQL is awesome, right, in that you can create all sorts of crazy schemas, you can use triggers, you can do all sorts of neat stuff. But then, you know, it's kind of hard to make that scale. It's expensive. Like we have some NODB installs that we have like thousands of writes a second on them, but then we have gobs of memory on that box, and it's using plenty of CPU, and then we've got some fancy RAID array behind it to have the I/O keep up with that. So that's sort of hard to really scale up on writes. Then also, so RD has rollups, meaning like it keeps the resolution for like 1 second resolution, and by the way, it also will keep it for like 5-minute resolution. So if you want to see a zoomed out one, you don't have to at the time for a year calculate from all the seconds that year happened. Now, if you do an SQL-based tool, like it's a little less clear how you do that. You could do it with maybe stored procedures in different ways, but it's not totally clear the best way to do that in that case. The other thing is SQL databases are sort of notoriously large on disk for the amount of data you're storing, physical data. I mean, rule of thumb for a lot of data is like 10x the size of your data is what the on-disk format's going to be. And like I said, the disk doesn't matter, but sorry, I didn't get back to the thing. The problem is, if you want to read this stuff a lot, it's got to be in cache too, and your memory is certainly more expensive to you than that ever-cooling disk. The memory is growing, but not at a phenomenal rate. And so then OpenTSDB, it exists. I don't know if it's actively being worked on today. I sort of maybe heard somebody saying it wasn't, but I don't really know. Just check into it if you're interested. But it has no rollups, so they don't have that function. If you want to query a year, you're going to be summing up a year's worth of data. It's even larger on disk. If you enable all the compression, LZO compression on the records, I think are 39 bytes per record. It gets it down to 12 bytes per record. So, you know, it's a fairly large amount. And again, that hurts cache. And then it has some pretty deep dependencies. If you're already bought into the whole HBase Zookeeper stack, it's not a big deal from you. But if you don't use those technologies, you're going to be adopting a very large application stack just to track your metrics. So for the front end, there's basically 2 classes of tools. And I'm kind of setting aside a lot of the closed source commercial tools. I know they exist out there, but they're all pretty expensive, and they're pretty hard to find out about and really give good information on, because they all want you to like sign up and get a sales rep to talk to you before you can look at their stuff. So we don't know a ton about those, but we've researched them some, and I'm just going to exclude them. So RD-based tools. Well, from the front end, basically for all of them, you're looking at bitmaps. That's not always so cool. Pretty much all of them, like cacti, ganglia, all these things, they're mostly all written in PHP. For some people, that's a plus. For us, we're not a PHP shop. Not really, I mean, no insult to anybody. I'm not a big PHP fan myself. They have limited search. You can organize your reports in tabs and whatnot and walk through that, but when we're talking about having thousands to tens of thousands to millions of metrics, walking through a directory tree is not going to be the way you're going to find what you want. And then also limited data interaction. There are a few tools that do some funky things with like, you can drag over your bitmap and it'll go, I'm going to request a new bitmap in this range from RD and stuff, but that's not so great. Existing cloud tools, they're not bad, but they tend to be expensive at scale if you want to do the kind of scale of stats that I'm talking about. They're closed platforms. They maybe have some APIs, but you don't have a lot of reach into those. And then there's single vendor solutions. So even if they did offer a way for you to expatriate your data out of them, you got to figure out now how to load that data into some other system. And probably going to lose some metadata. I mean, like, who knows really how easy that process is going to be. So if you're picking a cloud solution, you're really committing to it for a long time, and you're committing, if you ever switch away, probably to leave all your old data behind. So this is a graph that actually exemplifies why I started writing this. So we were having some performance issue at Spinner, some kind of operational issue. I don't even remember what it was. It was quite a while ago. And what I wanted to see was a graph like on the top, or I could say, okay, this is what's going on. But instead what I saw was a graph on the bottom. And these are the same graphs. But what happened here is there was an exceptional event here all the way on the right of the graph. And so when you asked RD to draw that graph for you, it's like, okay, here you go. I've auto-scaled the graph for you. And you basically have no information on that graph. What you can learn from this graph is that there was a low level of load, and now there's lots, right? It doesn't really tell us very much. So we think it's time for a new tool. And so we started building one. So, but what are our kind of goals? If we're going to rethink how to do this, that thing, if we're annoyed with these various problems with these old ones, what do we want? So let's set our goals high. We want to be able to scale to millions of metrics. We want to be able to scale to thousands of clients, and I mean primarily writers to the database, but you should scale well on the readers as well. For operations, largely it's a write-side problem, not a read-side problem, but you don't want to fall over if you do have a lot of readers. We want rich interaction with the data. We want to be able to, when we see that graph, we want to be able to say, you know what, but I don't care about that, but let me look at that other part of it, the graph, and I want to see that at scale. So we want to understand it. And we want more than just data visualization. We also want analytics. We want to be able to, and that's sort of a vague term, but we want to be able to really take this data. We want to collect all this data that we almost never are going to look at. 90% of the data I propose that you collect, maybe even 99%, you're never going to look at. But when you need it, it's going to save you, it's going to make a problem that might have taken you weeks to possibly minutes. I mean, in the kind of situation I can think about, I mean, who knows whether we would have solved it faster, but so we host in SoftLayer, and we're generally very happy with them, but we had a problem about 6 months ago that was really painful, where we were just having degraded performance, and it took us about a week or two to convince ourselves that this was really a network problem on their hand. And they were like, no, it's not a network problem. And if we'd had all these metrics to show, like, no, look, this is exactly what we're seeing on the network, all these kind of things, here's like repeated patterns. It turned out that one of their switches, their core switches, was oversubscribed and the backplane was saturated. And just not having visibility, they apparently didn't have visibility into this. Like, why don't we have visibility into all these things? So we want data visualization. We want real-time queries. When you're in an emergency situation, you're not going to wait 30 seconds for a query to return. If you go to your browser and say, okay, run this query, or a command line, run the query, and it's going to take 30 seconds, you're going to SSH into some machine and start like poking around, and you're going to forget about that query you ran. Your system's basically not going to be used in its most critical time if it doesn't return quickly. So we want things to be fast. Simple dependencies. Like I said, OpenTSDB, you got to swallow HBase, you got to swallow Zookeeper. It's a very heavy stack. We want this to be easy to install. It shouldn't be hard to use. We also want it to be inexpensive to run, but we want you to scale way up. We want it to be 10 to 100 times cheaper than the current things. And we mean cheaper than running Ganglia yourself. That's not free to run at scale. We'd like to make it cheaper. We'd like you to then take all that extra capacity and use it so you have more transparency. We also think it needs to be highly available. So there's a large feeling that you hear people say, well, this is just metrics. Like, it's Ganglia. We'll just send UDP and we'll hope it gets there. And it's just metrics if you don't, right? That's not your mission critical data, but it is, right? If you have an outage, every minute you're down is costing you money. And if you don't have that data because your network's fucked up, like what if your network's saturated? UDP is going to lose a ton of packets, and you're just not going to be able to get the metric. You're not going to be able to see the data that Ganglia is trying to tell you about what the problem is if you have a network problem like that, because it's just going to fire off that UDP packet and it hopes it gets there, and if it doesn't, it didn't really matter because you weren't using it, right? So the other goal we want to have is we want to have out-of-the-box host monitoring. So we want to ship with a whole bunch of plugins with rich metadata that really tell you things. You shouldn't have to go and like configure tons of graphs to get something useful. You should be able to install this, and it should just do something useful for you right away for the basic kind of system things. Certainly I/O, disk, memory, CPU. We'd also like to have plugins for MySQL and other like Apache right out of the box so that you can monitor those as well in sort of deep ways. So those are our goals. So let's talk about the implementation we're working on. Now, what I'm going to talk about now, 95% of it is completed and working in that demo. There's a few things that aren't done, a few things that are partially done, but I'm just going to talk about what our goal for version 1 is, and we can talk about more later, I guess. So the high-level concepts are that if you want to build a scalable, distributed kind of system today, we think these are some of the core things you really have to think about. You need to be sharded. You need to be asynchronous, and think message passing is the right way to handle that asynchronous nature. Really, if you're doing networking, you really should be using ePOL. And we think one of the core concepts that are really powerful are write-ahead logs. And you'll see we've used these fairly heavily, and we'll probably use them for more things. Log structured data is great if you don't need to read it off disk. If you've already got it in memory, it's the fastest way to write it out to disk. So we have some components. So this is roughly what a sort of sample cluster would look like, the vertical cluster. So we've got a few components here. So this, of course, would be the browser where you're looking at the data. And then we have a web server, which connects the browser to the backend database. This component DB provides all the metadata about all the metrics that you have and all the reports you have and charts you have and the application in general. So the whole application is data-driven from the metadata about the metrics and charts and reports you've got in your system. So then we have our metric Ds, which are actually our indexing servers. And so those are sharded horizontally. And you can just add another one and start provisioning new metrics on it. We use a routing table stored in this route DB, not like consistent hashing or one of these other sort of like automatic ones. And because in the end, none of those really work well when you want to add one more of a capacity and not have to reshuffle everything around or stuff like that. You can do it fast, and you might as well just build a routing table. Most people end up with that anyway, even if they start off with consistent hashing. They keep to the point where, well, really, you should have just built a routing table to begin with. Then we've got machines we're monitoring with the local protocol daemon on it. That's client D. And then we have Nuon here that I haven't connected because everything needs to talk to it, which is our management server. So the general architecture is that the management server is what coordinates the cluster. It's what you get your bootstrap information on. It's what you go to when you provision new resources on the cluster, and it's the single decision point in the cluster. But it's not a database. See, it's not a cylinder for those people that complain about cylinders in their diagrams. It's server, and all the machines in the cluster know its IP address and just connect to it and start reporting their current state. So even if that thing crashes and you got to replace it, within a short period of time, it'll know about the cluster again. And you can put it on a virtual IP. It's not the best availability solution, but it's one that's scaled really well. I mean, it's how Hadoop works, it's how GFS works, and it's how Lustre works. There's a lot of systems that show that you can put the metadata in a single point and do lots of caching of metadata throughout the cluster so it doesn't have a high access rate. And then you can get really good scalability with still having a single point. And we make that available, reliable and highly available by not actually needing any permanent data in it. So to go into a little bit more detail on all of this stack, what we have is first the in-browser application. So this uses a Comet-like API. We don't actually, it's whatever. The point is like a long pole solution. So we don't use a lot of connections. We use message passing all the way to the browser. So the same message passing protocol that you do to talk to the database server, the browser talks. And the only difference is the browser emits it as JSON, and it gets converted on the way into our own wire format for our own network. We do all our visualization on top of the SVG canvas. It gives you really good interactivity. It lets you do really fancy things. It lets you do dynamic graphs that move like you saw. Canvas is cool, but you can't just like update one line in a canvas. It doesn't, or if you want to, you have to deal with that, and it's going to be hard to get hardware acceleration for that as that starts to be rolled out in browsers. You're not going to get like, an OpenGL backend implementation and hardware acceleration on your canvas element. So SVG is a nice choice. We're also query driven, like I said. So like, I still have this one I showed you. It's like even all the menu bars up here, all these things, these are just the results of a query, what we put up there. Those are just reports that happen to have the tag core. And we say, well, what's in our header? It's all the reports with the core tag. And we just query for all the things with the core tag, and we display them there. So we're heavily query driven. And it's actually more than just regular queries, and I'll maybe talk a little bit more about this later, is that we actually built we're building all our databases streaming databases. So you don't actually make a query for information, you make a subscription. And you get a set of initial results, but if it changes, you get that update as well. So it's kind of fun when we're like doing a big load in the component database. You can start the application up right away. And not all the UI elements are in the page yet, but if you just watch, they'll just start appearing. And as not all the elements of your search are there yet, but if you watch, your search will just get more and more results over time as they're loaded in the database. So it really does stream stuff and keep the queries open. And then we use a reactive templating model for anybody that's sort of at all into doing dynamic HTML, JavaScript, browser stuff. So we get good dynamic updating without having to re-render the page every time. And as you saw, we have an interactive application. So then that talks to SWeb, our web server. So this is really primarily just a protocol proxy between JSON and homebrew format we use called message data. If somebody wants to talk about that later in the Q&A, I'll say why we use that. And it provides the other side of the API. The only thing it does that's not proxying is we put some logic in there to rescale the data because we want this to be fast. And in our early experiments, we didn't. We just took the data as the database gave it to us. And our query model is we guarantee that the results of your query will satisfy the query that you gave us, but it may give you more data. So if you ask for, from 4 o'clock to 5 o'clock, it might give you from 3 o'clock to 6 o'clock in the result set data. And if you asked for, I want to be able to see at least 5-second resolution, it might give you 1-second resolution data. And this is to reduce the load on the database server. But it turns out that one of the large bottlenecks in terms of performance is your throughput from the web server to the browser. So we have some services on here to prune and rescale the data to match closer to what the browser actually asked for, just to reduce download size. Then we have this component DB that I was talking about, which is what drives that whole application. So this, like some other databases you see we have here, it's an in-memory database, but we have a write-ahead bot log as the back end. So the general goal with this approach is to get something that can be a very high-performance in-memory database, but that if it crashes, you can recover and you haven't lost everything. So you don't have to have these people that use memcached as an actual database, whether they admit it or not, have this huge problem that when their cluster goes down, they have to warm up their whole cluster by loading it out of this other database. We can just replay a log, and it doesn't take very long, and get back to where we were. I said it's a streaming database. We have subscriptions and not queries. And we have resync on our streams. So that means if you missed the message, the protocol is such that you can see you missed the message, and you can say, oh, by the way, please resync me to this point. Then it will do that. That's not fully implemented, but the basic protocol implementation is there, and most of the back end is there. We just haven't finished the final steps. But what you realize that actually is partial replication. And so if you just queried for everything, it would be full replication. So we haven't built one yet that uses that to replicate, but it should be a fairly trivial process to actually build replication with that. So then we also in this component DB can do special indexing. If we want to say, give me all the records that implement this type and have these tags, we can have sort of type inheritance and say well, you asked for the data type and annotations match the data type and metrics match the data type, so I'm giving you both annotations and metrics. So clearly you could do this with SQL database, but we wanted some other things. So we can do, we wanted these other features that it's harder to get out of the SQL database. But we could have implemented an SQL database, but we like the lightweightness of this and the options to easily build arbitrary indexes and stuff like that. So that's what that's about. Then we have sclientd, which is the local collector. So we guarantee delivery on messages sent to the back end when you're emitting messages because we think they matter and we don't want you to lose them. But that has some complexity, and you might be writing to one of n different servers, and that adds complexity. And we wanted to make the clients easy to write a lightweight client to emit metrics into our thing. So this daemon handles retransmission and routing, and then you can just connect to it over Unix domain socket with a really dumb protocol, and you just emit a JSON message to it. And if it's not backed up, it has a very small internal queue, so you don't have to lose a lot of messages. And as long as the system is working and the network's up and everything, it will take that immediately. Otherwise, it'll block. So the API is, can you make a JSON object? Can you make a JSON string that represents your emit? And can you deal with blocking I/O? And if you can do those two things and open Unix domain socket, you can write to this system. Again, it deals with our custom wire format and stuff like that. So then we have the route DB, like I mentioned in this architecture. All the routing is done through a routing database. So this is another in-memory database with a log. It has the same streaming, same protocol. We actually have basically a abstract virtual base database, and we can just build different ones on top of it. So if you can imagine your database as a key value store, essentially, with indexing on top of it, we can build it on top of this base database, and these are both instances of that base database. You can just query and say, hey, I have this metric name. Please give me where it exists for reading or writing. The metric D, which is our main server. So this can sort of be thought of as a log structured database, but where if you need to, you can rewrite log segments. Well, I don't know. Maybe that's not the right way to think about it. I don't know. It's its own sort of beast. So basically, when a metric comes in, you commit it to a write-ahead log, and you tell the person, like, yes, I've got your data. Then for a while, that just sits in a collector. So you're collecting that memory, you're aggregating, producing your different roll-ups, and then periodically you snapshot that to a constant database on disk and flush the memory. So what I mean by a constant database, I mean is that it's a database which is guaranteed to never be updated. It may be replaced, but never updated. So what this means is we don't have any like coherency issues with updates and race conditions in readers, racing with writers and whatnot. And we also can be very compact and have very tight indexing. Since we know exactly how many entries are in it, we can get to any tile in the database. So we actually store tiles worth of data to make things simpler. So you can't query for an individual record. You can store for a tile, a set of records. And you can get to any tile in like about 3 seeks. I think it's 3 seeks, assuming there's nothing in cache. And if there's enough locality, you'll get some of those together in a page that you read. So we support right now metrics and annotations, and we plan to support other kind of index types. Reads are done to be very cheap on it, so if you need to do a lot of reads, it's very cheap. The database doesn't do anything except read the bytes off of disk from the tile and send them out. It doesn't parse them, doesn't care, and it's up to the client to parse the tile and get the actual value it cares about out of it. So to stress, we do have like annotations. It wasn't a really great place to put this slide. I'll probably talk about it a couple times. One of the things we thought would be really cool is one of the things you want to know a lot is what happened in this graph. Like a lot of times you'll find, you're looking, about yesterday at around, if you remember 3, you rolled out a new version of your software. And then you notice that, oh yeah, over the last night, there's been a slow performance degradation. And it started right there. Now, is that when you rolled out your software? Or is that just happened to be near when you rolled out your software change? Was that before or after? And so we think that this annotations feature is going to be really powerful. And that what you should do is update all your init scripts, all of your, your on system restart, on service restart, on installing a new package, on rebooting a machine, on all these kinds of things. Just emit and saying, hey, I did this thing. And now you can overlay that information on any graph and exactly correlate when all those events happened with features on your graph. And so we think that's a really cool feature. Then we have this management server, which I mentioned. This is the thing that organizes the network. I think I already pretty much described that pretty well. And so now I'll give it a little more of a demo. So we were looking at this, and I showed you could zoom in on it and all that kind of stuff. And that's pretty cool. But we also have, I mentioned search. So what's the good one to search for, Leaf? OK. So we can look, and we get publisher type. And so we're actually searching by a tag. So we're actually for anything with a publisher type tag. And then we get all the graphs that have publisher type tag on them. And again, this is all loading in real time. This data we haven't seen before. We can, of course, we've got all these graphs together. They'll zoom together. It'd be nice if they were different colors. They're not quite yet. But this one's kind of annoying me. And I happen to know which one that is. So I'm just going to hide that graph. Oh, no, I got it wrong. It's this one. I thought I knew which one it was. And there we go. And we got that. Just remove that. And if we wanted it back, we said, no, actually, I do need to see that one on there. It comes right back. So we really do have rich data. It's really gives us a lot of power.
Hey, Jonathan, is the data cached on the server?
No, this is all remote data. Every time you see the data change, every time you see me pan the data across the screen, zoom in like that. That's really slow on this computer with 10 metrics on the screen. It's not the fastest computer, but so if we do back to this page, as we pan around, that's all. Every time I let go of the mouse like that and that loads, the thing between the low resolution and the high resolution, that delay was how long it took to go make a request to a server in DC, is that where our servers are, and get the data back here. So, obviously the system's not terribly loaded right now, but it does work pretty well. And then we've got also, I can do also, so I've also got, that's like I said, our, so that's, well, okay, see, sorry, just a second, let me get this right, and then I'll answer your question. So we have largely written that. It's based on top of a library called Protoviz, which actually we're going to replace soon with a successor that's called D3, but largely it's something we've coded all ourselves. There wasn't a good off-the-shelf do it. I strongly suggest if you're interested in this stuff to look at, I think it's D3. If you go to protobez, it'll point you at the new one, which I'm pretty sure is called D3. It's not a graph tool. It's a library for it's a graphics library for building visualizations. Yeah, it's pretty cool. Then in the new one's better. It doesn't hide the SVG canvas from you like the original one does, which is actually really annoying. And the new one doesn't do that anymore, and also adds animation support. So this is something code running on my box right here. I just started this morning, so I'd have some data. And so this is like CPU monitoring on my box. I don't want to see idle because that's scaling the whole screen. And all the other ones, I don't know why these are all blue, which is too bad, but they're there. But and then we could go over here. Like I like the entropy graph. My entropies are really fairly low lately, and I don't really know why. But here's my entropy. So this tells me how much entropy is in the random pool in the system. But look, and this one already has annotations on it. So this is syslog overlaid on it. And you can see that there's correlation between drops in entropy and syslog running. And that's kind of neat to see. Because when I first got this entropy graph, like it's been lower lately because I've been running something else on it apparently, using more entropy. But there would be like, you'd see it go and then there'd be just drops breaking. What the hell is that? When I first saw it, I was like, it really sucks knowing things because then you just want to know more. And then I added this syslog annotation to it, and I'm like, oh, it's the entropy drops every time cron runs. And that's where my entropy is going. So we got that. And this is really neat too, because it's not actually super useful on this graph, but let's say we're looking at memory. Well, actually here, we're looking at memory here, and there's this stuff going on. This is when I turned off the computer to walk over here. That's why there's a gap in the data. But you know what? I want to see syslog on this graph. So I can just type syslog right here and hit return. And now my graph here, if I go in, has syslog on it. Now, you might wonder, why is it that I have to zoom in to see these syslog entries? It's because our annotations, they're much like logs, except they have two features that your file on disk doesn't have. One, it's all indexed by time. So I can get any chunk of time, any tile of time very quickly. So if I want to know from this time to this time, it's very fast for me to find a particular area of time for my logs. The other thing that's really cool about it is that there's some events that you care about on the year view, and there's some events you only care about when you're zoomed all the way in. So let's say you have a cluster, right, of web servers. Say you're High Five down the street, and you're doing 1 billion page views a day, right? And you might want to look at the whole cluster for a year and say like, oh look, this is the whole cluster for here and there. You probably want to see software rollouts, right? And you want to see other major events when you're looking at the year, and those annotations you want to see there. But maybe let's now switch to one machine and say, well, how does this machine performing in the last week? And you probably want to see system restarts, and you maybe want to see Apache restarts or whatnot on there, as well as those software upgrades. If it happens to be over software upgrades, you certainly want to see it there. But then if I zoom in all the way to 15 seconds of time, I could actually have every single entry in my Apache log annotated on the chart if I wanted to.
Can I annotate Michael Jackson or Britney Spears when she released the album?
Yes, you could put Britney Spears on that. So you could put your own. If you had some exceptional event, so I did work at High Five, and so one thing that was an exceptional event for them was World Cup soccer. And so you could easily put a hand annotation saying oh yeah, this drop in the graph right here, that's when the World Cup finals were running, and that's why we didn't have any traffic right then.
Those are syslog events. If you want Britney Spears, you need chick log. Yeah, right.
But in any case, so yeah, annotations we think are really powerful. So you can specify. You do have to specify the right time on it, but we'll provide some UI in here so you can say what resolution of data you want. So you could look at that really high resolution data even when you're zoomed out. By default, it's not doing that. But so that's basically what this application looks like. And we have different things. Here's a number of processes on my box, and I don't want to see those sleeping ones. And so then I can see the other kind of information. But you get the idea here. The goal is to make this, and we're really just starting. So what we've been doing is we've been building the foundation and the building, and we're now getting to the part thing is going to be really fun because we get to sort of do interior design now, interior decorating. We get to take this platform and start building some cool stuff on it. And this is just the very beginning of what we think we're going to be able to do with it because we finally got all our groundwork done. We can start building stuff. Let's see. I think I have a few more points in my slides. So okay, yeah. So some numbers. So about where we are in the system. We're still developing with this sort of alpha software. It's early enough that if anybody really wants to play with it, we've got a really simple single system demo that you can just run a script and it'll run the demo once you install a few dependencies. And you can get that demo that we were just looking at, and that will just run really easily. And if you want a system like we have monitoring, so like the spinner system there, it's if you're willing to have some big bumps and big learning curve and realize some stuff doesn't quite work right, you could totally deploy that system now though today if you're excited about it. So currently a single dual core, dual quad core and a Hallam box can handle about 10,000 emits a second. So that's a fair number of emits. We'd like to do better. So, obviously, if you were tracking things once every 10 seconds, you could handle, and all your emits were emitting all the time, that's 100,000 metrics per box. If you've got some that are dense and some that are not, it might be a whole lot more. So this box currently we showed you some graphs, but there's actually 120,000 metrics being tracked on that box. I think about 20 or 40,000 of them are updating with some reasonable regular frequency. And on that box right now, we're using about 30% across 16 threads, 8 cores, and but the disk utilization across 3 disks is like 7% in IO stat. So it really doesn't use the disk for. We thought, when I started this a long time ago, my initial naive thought was being somebody who's worked a lot with databases for years, IO is always your problem. It was how do I get more IO? And so I was like, you know what, I'm just going to write this thing in Python. We're going to be IO bound. Who cares about CPU? But apparently, if you actually write a nice IO path and your problem lends itself to it, you can basically use very little IO for a very high rate. So we don't use very much disk right now on this at all. And our record size from the early data we have, if you look at, so we do some smart encoding to get the data size down, and then we do compression after that on the tiles. And it's around, actually I think it was before compression, so it might even be a little lower now. We're doing about 1 byte per tile, or per record. So for every emit that you do, which is a time value, well, actually is a triple, it's a triple, 8 bytes triple actually only requires about 1 byte of space to storage with just encoding. I actually haven't looked at it since we turned on compression. So, and why is it a triple? It's a triple because, so you ask, well, what do you store in your graph? You could store mean value in all of your aggregate buckets, or you could store a rate in your aggregate buckets. But sometimes you want mean and sometimes you want rate. So, what we just store in our buckets is we store the time that the bucket represents, then we store the count of number of items we've put into that bucket, and we do the sum of all the items in that bucket. So now you can get rate, you can get mean, you can get the total count, you get to pick later, and since we've got a rich client, we can just have it calculated in the client. So those clients were showing you rates and means and stuff like that, and I was just doing that all browser side to do that. So that is where we are with that. So we have our plans out for version 1, and we think that's actually probably November timeframe to get at least a beta version 1 out that's really quite stable and what?
Real beta.
Like real beta, stable, has all the features. There's no known crashing bugs in it. Maybe there's a few rough edges we know about, and some more that we don't. But something that we'd be totally comfortable telling people to use in production. So after that, we're thinking of more index types. So one thing we have some preliminary work on, but not really pushed into the stack, is sets, so there's this other problem, right? If you're running in the cloud or in even a large cluster, you're bringing machines in and out of services all the time. And so you want to look at, I want to look at the, database cluster 1 or web server cluster 1 a month ago and see what its performance numbers look like for CPU. But what machines was that, right? You reprovisioned that cluster and moved things in and out several times. So what data sets do I look in to find all those machines anyway? So we want to solve that problem with sets. So we've built the on-disk format and a little bit of stuff around it, but haven't built the client-side stuff for an efficient index that you can ask the query. You can say, give it a range of time. You can say, for this range of time, tell me all the items that were in this set in any time in the range of time. So and that we think is a really powerful query that will let you do all sorts of really neat stuff. RDS. I've heard of it, but I forget what it is.
The Amazon database, they try
Oh.
to often as much as possible.
Yeah, that I've had.
In monitoring, you release software and suddenly you're not sure how the RDS implementation is working, and it would be nice to have a little window into that.
Yeah, I don't know. If you want to record that kind of information in our databases, that's a great idea. I don't totally understand it because I haven't worked with RDS.
RDS is just MySQL in their
And
cloud.
they hide it from you.
Yeah.
They don't know a lot of
Yeah.
about it.
But it is MySQL.
It is MySQL.
So sure. I think. I'm not sure. I mean, what do you say? Storing in that or?
Well, they kind of take care of everything for you. At a previous job, when we had an engineer that wasn't too savvy in the DB world, we stuck him in RDS.
Okay. So what are you asking if we can do?
He would do a rollout. You would never know some of the metrics around it. Did
Okay.
the rollout cause performance to
Okay. Yeah.
drop?
Yes. This is exactly. We would say you should emit an annotation for that, and you have all these performance metrics, and then when you're looking at your metrics, you can look exactly when that rollout happened, and that rollout was done by your build and release tool. Your release tool emitted the metric saying, I'm doing a release right now to these machines. And then if you go look at those machines, you can see that metric and go, yeah, look, performance did just drop by 50%.
So you don't have SSH into that, so how do you find out the IO?
Amazon would have to publish some stats.
Yeah. Yeah. I mean, you could.
You have to have,
Well, I mean, I guess you could look at it from the other side. Your clients are querying it, and you could emit from the clients the queries per second they're doing and the query time that they're seeing against that database. So you could look at it from the client side. Yeah.
Amazon is a good example of why the analytics tools need to be better. Because Amazon actually has an analytics framework inside all of their products. It's called CloudWatch, I believe. And if you use it, it's even more primitive than Ganglia. And one of the big problems it has is that it shows a feature, for example, that StatMover does, where you can go back in time and look like a month view. But they store everything in high resolution. And so when you go to view a month view, it takes like a minute and a half to load that little graph because it goes and fetches all the data off disk and then builds that minute and a half graph. It takes like a minute and a half. So, but with Saturnalia, it's instantaneous.
Yeah. So we want to work some more also on CPU and memory usage. We may move the code over to Python because that gives us a lot more performance options, and maybe move some of it to C or C++. One of the things we're really interested in, but is definitely a post 1.0 feature, is anomaly detection. Like, you've got a million graphs. Wouldn't it be nice if we could just tell you, like, here's some that are behaving weird? Alerting, like our initial version is going to have like command line tools and REST APIs to hook into your alerting system, whatever that is today. But, you know, it would be nice if it was integrated. It would be nice if you could go to a graph and just like draw a line on a graph and say, you know what, if this metric either ever goes above this high water mark or go below this warm water mark, send me an alert. It would be nice if it was integrated in like that. And let's see. Oh yeah, so we're also thinking more integration points. Right now we have this client D. We think the protocol is really simple, but you know, maybe you want to emit to us with our syslog D, our syslog, because you don't want to install any software on your machines. We'd like to do that. You know, we have other kind of APIs, stuff like that. That's sort of stuff we'd like to, you know, and especially we'd like to hear what people think is really exciting, because we need to figure out what we're doing next. So also though, this is the only bit of this that's anything like a pitch, because all the software is open source. It's MIT licensed. It's totally free. You can go download it from the public repository on Bitbucket right now if you want. But we're also going to have a hosted version. And the goal here is to take the WordPress model. We want to make software that you can run yourself, but we want to run it so much better than you would that you'd never think of doing that. So this is probably more of a 6-9 months time frame to see that. But you should definitely, if you're interested, and you know, we're going to be hiring soon if anybody's really interested. So that's basically the talk that I have, and I guess it's sort of time for questions.
Are tags a per metric or per host item?
Tags are a per component item. So there's that whole component DB, and everything in that is components. And so there's components for metrics, and components for charts, and components for reports, and components for tags, and you can put tags on tags, and there's a tag on the tag.
Annotations can have tags?
Yeah.
What I mean is an individual metric submission can that have individual tags?
No.
It just came from the source.
No. It's all metadata about the metric. The individual items don't have tags, but it's the metric that has tags.
I may have missed this earlier on, but how do you get the units in there?
How to get the units in there?
Yeah.
That's metadata on the metrics or the charts. So right now, I actually is pulling it off the metrics. I think. I forget right now. But yeah, we've got this rich metadata about it. So when you provision a metric in the system, you can give it some metadata about it, saying this metric is in these units. And you can also say, and by default, you should probably display it as a rate in foos per second or per minute or whatever you want. Mm-hmm. So the way it works, so that's a really good question. So if you want to see, you have bytes per second on ETH0 on this machine, and that should be a record, emit. But then you want to say, what's my total bytes per second through all of my public interfaces, right? And so the way you do that is you could do that by tagging each of those and pulling all that data in, and in the browser doing the aggregation. But that would be really slow if there was a lot of things. So the other thing you can do is when you emit that metric, you emit that metric as host 001, ETH0, TX or something like that, right? But then you can also just implement, you can also just have that as, you can also emit that metric twice and also emit it again as external, external pool TX. And then so all the machines are emitting to the external pool. So we're thinking about adding support in sclientd to automatically do that mapping for you. So you can go configure. What? No, you don't. Well, because it doesn't it's kind of hard to do because you can't really do it in the collector because this is a sharded database, right? It might be that half the data goes to this database and half the data goes to this database. So the data collector database can't possibly pool both of those together. You've got to.
What's the partitioning hash that you're using?
There's no partitioning hash. It's just chosen on machines. So when you provision a new metric, you look at the load on the machines, you decide what machine it goes on based on available resources. And so over time, it's very likely that two machines in the same cluster are going to end up being provisioned on different databases. So you need to get the data. You need to get all the data to one database anyway. So instead of trying to putting special logic into the collector database, just go, oh, this one, I'm going to take it, and I'm also going to send it over here. We just put that burden on the client to decide where to send it in the first place. Like I said, right now you got to do that yourself. We are planning on adding support into the sclientd to do that for you automatically, so you can then go into your web management interface and say, oh, by the way, this metric, every metric, or take this, search, find these metrics, and all these metrics that have these tags on them also emit to this other thing, or whatever. You can we'll build tools to make that automatic. We haven't decided quite how we want to do that yet, because basically we want to do some deployments ourselves first. And so since we've got a large internal customer at Spinner, we want to do a really good deployment for Spinner and really understand what our problems are there, and hear from the community as well as other people start to install this, and figure out what are the real tools we want to provide for that kind of stuff. Because I could make some stuff up right now, but maybe it's not what you need.
Circle around and make sure I understand that. If you could find a metric of a particular Ethernet interface that's being collected in one database,
Mm-hmm.
have an aggregate metric for all of your Ethernet interfaces, that would most likely go to a different database. That's why
If you had a large cluster of collectors, yes. Or of collectors, yes. Yeah?
Yeah. So on the sclientd, so that's a daemon that's running on your client, right?
Yeah. Let me. There we go. Yes.
All right. And you had mentioned before that it's blocking and you actually have to in your app connecting to it, you have to that possibility.
Yeah. The reason we chose to do that is because we sort of have three choices. We can block when we can't send things out. We do accept it right away. It's only blocking if it's backed up in its short internal queue. It has some short internal queue. But one of the core principles that I haven't mentioned that is in this design that I should have put on that high-level thing is that we try and constrain every single resource. Because one thing I've learned, so this is not the first distributed database I've built, and the first thing I learned, that one is you're like, you know what? We're never going to hit that number. Let's just ignore that. And you find oh, I'm forking every time, or I'm running a new thread every time this thing happens. And so when that remote thing blows up, now I've run out of processes in the process table on my box because I just consumed all the threads. So when you've got these distributed systems with lots of events going through them, things can blow up at any time. So you actually want to put a hard limit on everything. So we've got a small amount of internal queue, but once that fills up, well, we have two choices, right? Or three. We can spool to disk, but that's another resource which we also have to block. Eventually, all the queuing is going to fill up. There's some point at which all of queuing fill up, and then you're only left with two choices. You can block, or you can drop that message. But we think the stats are really important, and we really think if you're going to drop that emit, that it should be the person sending it to you that makes that decision. Because we don't know anything about your code. We don't know, is this one really valuable to you? And maybe it's not. Maybe it is. So the reason we chose to do blocking is because we thought that that was the easiest way without a two-way API, which is way more complicated, to communicate to you that we can't handle that emit you're trying to send us right now.
Can you go into why it would be important for, like, if, for example, the metric D is overwhelmed, what an S-client D would do if too many messages were coming in?
Well, I guess, I feel like I just said that, but
Wouldn't it spool the disk or something?
no, it doesn't spool the disk at all. We could add spooling to disk. And I thought about that, but maybe you don't have those resources. Like, maybe you don't want this emitter daemon on your local box to be heavyweight and have to have all these extra resources. And eventually, you're going to fill up the disk. So in the end, I think it comes down to you got to drop the message, you got to block, or some other way signal to the caller that you can't accept the input. And it just seemed blocking was a really simple API, and it's really not all that hard to use right with a timeout. Like, there's lots of easy APIs to just say, write, but don't take longer than this many seconds, right, or milliseconds. And so it's not that hard an API to use. Like, yeah, it would be nicer if it never blocked, but that's inconsistent with letting you decide if you should drop the message or not. No. So you could actually, I was saying how we collect stuff and we dump it out to disk and jump it from memory. If you write to something that we don't have in memory anymore, we'll load that junk back into memory and start updating again. We have all the information we need to update the data. So if you make us, so we're going to have policy options that you can configure to say, don't accept metrics that are this out of order, like have a maximum, have a window. We don't accept stuff this far in the future or this far in the past. But that's entirely a policy decision. So another real design principle is try and make everything policy decisions instead of inherent design principles. Like if something's possible, we try to make everything possible and then let you write rules to say what should be allowed.
And then do you read through what's in memory? Like, is there a flushing mechanism for getting like absolutely up-to-date time window, like if you're trying to look through those?
So the way we're going to handle that, so right now, in the current deployed version, you can't read anything that hasn't been written off disk. And I think we write to disk once a minute right now. But that said, so we've got this whole streaming subscription protocol. And so the idea is to put metric D is one of the oldest pieces of code we have. And it sort of has some of the earliest ideas we had. And it was always an intention to put something like this in it. Now we actually have a good protocol designed. And so the idea is what you'll do is you'll subscribe to that metric. And so as new events are being emitted to the collector, as values are changing to the collector, it'll send those to you streamed. So you'll query for them, and you'll maybe read some off disk, and then you'll also be subscribed to any changes as well.
What about configuration? Is it going to be all GUI, or are you going to do a combination like Cacti does with command line? You can choose to do it, or GUI?
It will certainly be configurable through the command line. If it's who knows exactly where to take it? It may be the configure with command line means you run a query and it returns you some JSON, and you rewrite the JSON and send it back. We do have we do offer strong consistency on a tuple level, so a row level. We don't offer transactions over more than one row, but we keep like transaction IDs or serial numbers, whatever you want to call them, on every single row. So when you do an update, you have to provide the transaction ID that you read it from, and if those no longer match, your update will fail. So we don't allow blind writes. So there's some back and forth you might have to do to use these tools. But we have command line tools that you can query all these databases with right now, and we have like command line tools.
For configuration,
Yeah.
a new box, and you got to
Yep.
set it up.
Yeah,
That's a
absolutely.
pain point.
Yeah, no, absolutely. We have this. We don't have GUI configuration right now. I've been using. I've never developed software for any other operating system than Linux in the last 15 years ever. Well, no, I guess it's true. A long time ago, I did some System 7 software development and some weird tools. But basically, you're not going to see. You're going to see a Unix tool chain from us. That's what you're going to see from us.
Is actually one of the reasons we're hiring. Like, improve the GUI is one of the major reasons we're.
But we want to provide really so.
That can be painful if you've got
Yeah.
100
Well,
boxes you're
but what we want to do
setting up,
so.
unless you do command
No. So obviously there's command line tools to provision the metric originally, but then how do you build charts and reports and stuff like that? There will be ways to do that command line, but we also want to provide really powerful tools. We want to say, like, we've got all these search tools. So let's say I want to search for this and this, but not this, and I want to take all those results and I'll put them in this chart, and oh, by the way, add that on as well. Or let me find this set, I want to remove this tag or add this tag. We want to provide really powerful query-based tools for doing that. And they will initially be in the GUI. They may eventually also be on the command line. What we probably won't write is, because we don't really want to, and we're going to have the web GUI, we probably won't like interactive curses applications for you. There probably won't be something really equivalent to the MySQL console, where you've got a curses history and all that kind of stuff. But there will be tools that you can, in Perl or Bash or Python or whatever your preferred language is, construct some queries to send to the database and get results back. So for scripting, we'll have tools, but not for interactive console-based stuff. Any more questions?
We use StatsD for application metrics or applications
Mm-hmm.
will update in context of request. So we'll have far more movements than per second. So we'll say this one took this long, and it will spit out every second an aggregate of
Using StatD?
StatsD, yes. Well, we have our own custom implementation, yes.
Okay. I was gonna, the StatD that you can download that's open source is actually what was running the system demo on this. It's Collecti. It's Collecti, StatsD.
StatsD, yes.
Right.
Okay. Anyway.
Right. StatsD is just a little aggregate.
Yeah.
StatsD specific for Apple, we use ganglions.
Yeah.
Mm-hmm.
But
Yeah.
we have like a counter, so we have an increment. So I said I had this event,
Yeah.
populate this event, and then that pushes it back in. So if I start sending you more than 1 second resolution, will it just start emitting this into metric E, or will it hold those up?
So we're thinking of putting that kind of feature into sclientd. Right now, it will just send them to the collector, and the collector will deal with aggregating them. But that will drive the emit rate on the collector. But if you want to do local collection, so you can send both single events and aggregate events to the sclientd. So if you've pre-aggregated, like if you're looking like a performance counter in the kernel, and it's like doing thousands of events a second or something like that, and you want to locally collect before you send it, that's also supported in the protocol already, and we're already sending data to it in that manner.
Sorry, so the system goes down to 1 second resolution?
It goes down to 1 millisecond resolution. I mean, you configure on the back end, so it's a configuration option as to because you choose what the roll-up times are, and you say, so I want to roll up at, so I think this the demo on this box rolls up at 6 seconds, and then powers of 6 up, and then the demo that's on the Saturnalia side, I think the lowest resolution is 1 second. And so your choice between rollups are, every rollup requires reading written to a different file. And so your choice for the rollups are, the more rollups, the closer you have to exactly the data you want at any resolution, but you're paying more IOs. And obviously we're not using that many IOs. We should probably have more rollups than we have right now. But right now we have rollups at multiples of 6, so we are always within 5x of the data you want on disk. And our data files are really quite small. They're only like tens of K for any tile, so they're pretty small already. And that gives us from 6-second resolution up to, from the smallest aggregate is 6 seconds to our biggest aggregate is 12 days. So we can efficiently show over several years worth of data down to fairly high resolution data in the default that we got in the demo. But it's configurable. If you wanted 1 millisecond resolution, we could do that. I'm actually thinking of redesigning the lowest level resolution so it doesn't actually aggregate at all at the lowest resolution. So it actually can have, so the lowest resolution will just be it won't aggregate the points in the buckets, it'll just list them all. So you'll actually have millisecond level resolution for your data at the lowest level.
What sort of aggregation method?
So it sums the value and counts the number of things in that value. But like I said, the lowest one I think I may change so that there's no aggregation at all. So there'll still be a limit on how many things can be in the bucket. It may have to turn on aggregation. I have to think about it more. I've just been thinking about that at the back of my head the last few weeks. So then if you're emitting at exact millisecond timestamps, I can tell you this happened at exactly this millisecond. If
Your buckets are just 1 millisecond.
no, probably the buckets, well, whatever. I mean, it's just at some, if you get down far enough, you could just log everything, right? But you're not going to be able to ask for very much of that at a time. Yeah?
It brings up some interesting points. Can you talk about what your sort of philosophy is for managing that data? Actually, so let's say you collected too much data and you need to throw stuff away, or you don't care about anything for years, or
Yeah. Yeah. So what I said is the thing about RRD is you have to decide ahead of time how long you want to keep data, and we think that you should keep data as long as you want it, right? So if you don't care about data older than 3 years, so all the chunks are all a time series of chunks, and the database doesn't know anything special with them. I mean, it's actually, so another thing we did too that I haven't mentioned so far too is that sort of related to this is that all of this is crash-only software. The only way to stop any of these processes is with kill-9. There's no clean shutdown path at all. There's only dirty shutdown. So we test all our recovery code every time we restart. That's good news. And that means we also know that it replays reasonably fast in most cases for things that replay in logs. So this also means some cool things too. We've got these very simple files, and we know the order they're written in. So we wanted to be backing up this demo because we want to have some data in here to show you. We can show we could zoom back weeks and stuff like that. And we've been running this current version for about a week now. But we were like, oh, what if that machine crashes? We don't have our replication ring. Well, actually, it turns out that backup is just copying the files in the right order. And that's the same as crashing the server. So in terms of deleting it, if you just didn't want 3-year-old data, just go and ROM those files off disk. All the files have their timestamps and them that they cover, and you could just delete them.
All the 1 second data, and if you don't care about it, then
Right.
you're left with all the other stuff.
Yeah, you'll still be left with the other ones. It will have, so one thing that could use some improvement, and I did some work on, it didn't work out, it didn't matter, so I just stopped, is that if you have that high resolution data, then you zoom in past what you have, you'll just go to a point where it stops returning data and you've got nothing anymore. And you'll have to zoom back out to see something. I would like to change it so that if it tries to get data that's higher resolution, turns out it's not there, it just snaps up and shows you lower resolution data. And so right now it doesn't do that, but that would be kind of cool if it did. But yeah, you could just delete the high resolution data if you wanted to. Yes? So right now, if you try and go to the URL in the demo, you'll find a .html, you'll find a HTTP off challenge. But so the real goal, that's one of the features that we plan to have for the stat mover release of the software. And the plan for that is to use a Kerberos-style ticket system. So we'll add a new component here, which is the authentication server. And before you can perform any operations on the cluster, you have to go to the authentication server and answer the challenge, and it'll give you a hashMAC ticket, or maybe now that there's maybe a public key ticket. I don't know. Hashmacks are simple, but then you've got to have use keys distributed everywhere. So maybe it was public keys. Not really sure. And then we'll add all the messages. So we've got a message passing system, and we're going to extend the messages so that all the messages include. So what your actually ticket you get back is a set of capabilities. So all your messages will have the capabilities you have on them, and so the services will simply check whether you have the capability to perform the operation you want before it does it. I don't know if that's the kind of answer you wanted, but
Right. So that's from the web.
No, that's from everywhere. I don't plan the web server to check to decide whether to send messages back. The web is just a proxy. It's just going to proxy those messages right through the browser to wherever they go. I mean, and if we want to put a capability on every single record in a database, we can do that too. Right? The great thing about writing your own database, you can do whatever the fuck you want. Any more questions? All right. Thank you very much.